Right. So in today's lecture, I will be teaching about how to solve the signal flow graph using Mason's gain formula. I taught you what is Mason's gain formula. P is equal to 1 by delta summation K Pk into del K, right? So all these, what is Pk, del K and everything is already given in the formula which we have also discussed in the previous class, right? So now we will have to solve the given problem using the Mason's gain formula, right? So now what is the first step is that we will have to find out all the forward paths. We need to find out the forward path that is present in the given signal flow graph here, right? So that means that we have a node number 1 which is a R of S and node number 5 which is a C of S. So in forward path means you will have to start with the node number 1. It has to have a forward direction 1 to 2 S, then 2 to 3 that is also forward direction, then 3 to 4 forward direction, then 4 to 5. So we will have to find out many number of forward paths in the given signal flow graph, right? So here if I say that we have 1 to 2, then 2 to 3, 3 to 4, then 4 to 5 is the first forward path. So I can take it like 1 to 2, then 2 to 3, then 3 to 4 and 4 to 5. Now if I look at the gain values, this value is G1, the second one is G2, the third value is G3, then fourth one is G4. Okay. So this gain value has to be written as P1 is equal to G1, G2, G3 and G4. We have found the first forward path and we have written the gain value for the first forward path. Then the second one is we have 1 to 2, then 2 to 3, then 3 to 5 also is there. So we can take that as a second forward path. So the node numbers are 1, 2, then 2 to 3, then 3 to 5. We will have to write down the gain values G1, G2, then from 3 to 5 the gain value is G6, right? Now write down the given gain values G1, G2 and G6. We have just found two forward paths of the given signal flow graph. These are the node numbers that is using in the first forward path. This is the second forward path which we have identified, and this is the gain value that we have got, right? So as well as you will have another thought is like, yeah, there may be another forward path like 1 to 2, then 2 to 3, 3 to 4 and using a gain value of G5 and then 4 to 5. There is a condition is that if you are using a node once, let's say if the 1 to 2 if you have used, you are not supposed to use the same node again while writing the forward path. Okay, so G1 to 2 if I have taken, then 2 to 3, then 3 to 4. This is a one loop, right? So it is starting with 4, then it is also ending with the same node that is given it over here. So this can't be taken as a one forward path, right? As well as we will also not be able to find out any other forward path in it, right? So we have two forward paths in the given flow graph, right? So the next step is that finding out the individual loop. We will have to find out the individual loop in the given signal flow graph. Individual loop is that it has to start with one node and the direction has to be in the same forward direction. Then it has to come and end with the node that we started over here, right? So I can take this as a one individual loop. So 2 to 3, then 3 to 2. So there the gain value is minus H2 and this gain value is G2, right? So as soon as you write down the first individual loop, you will have to write down the gain values of that. So this has to be written as P11 is equal to minus of G2 into H2. And the second loop we will be able to find out, and here we have a one loop with the node number 4. So I can take this as a one loop, because the condition for finding out the loop in the given flow graph is that it has to start with the one node and it has to end at the same node over here. So here we can take this as a one loop. So that gain value is G5 and this node number is 4. So P12 can be written as G5. The gain value of this loop is G5. So P12 can be written as G5. Okay. So there is one more loop also we will be able to identify, that is this loop 2 to 3, then 3 to 4, then 4 back to 2. The node numbers 2 to 3, the gain value is G2. Then 3 to 4, the gain value is G3. Then the feedback gain value is minus H1. Is it correct? Yes. So we are able to identify the third individual loop also. The third individual loop gain value can be written as P13 is equal to minus of G2, G3 into H1. Right. So is there any other individual loop present in it? Okay. 4 to 5. Okay. 2 to 3, then 3 to 4, 4 to 5, 5 to 2. So we can write it like 2 to 3, then 3 to 4, then 5, then 5 back to the node number 2 with the gain value minus H3. So this gain value is G2, then 3 to 4 gain value is G3, then 4 to 5 the gain value is G4. So this gain value of P14 can be written as minus G2, G3, G4 into H3. Correct? Right. So is there any other individual loop present in the given signal flow graph? Yes or no? Yes. What is it? 2 to 3, then 3 to 5, then 5 back to 2. Right? So that also can be taken as a one individual loop. Right? So I am writing down that the individual loop 2 to 3, then 3 to 5, then 5 back to 2. So that gain value is minus H3 and this value is G2. Then 3 to 5 the gain value is G6. Right? So we can write the fifth individual loop gain value as G2, G6 and minus H3. So I have written as minus G2, G6 into H3. Is there any other individual loop present in the given signal flow graph? Yes? Yes or no? Yes? What are the loop, what are the node numbers? 2 to 3, 3 to 4, 4 to, we have already drawn that, right? 2 to 3, 3 to 4, then 4 to 2. We have already taken that as a one individual loop, right? So we were able to find the maximum of 5 individual loop in the given signal flow graph, right? So if we have stopped with the finding out the individual loop, what is the next step? We will have to go for finding out non-touching loop. We will have to find out 2 non-touching loop in the identified individual loop over there, right? So now, what is that 2 non-touching individual loop is that? one loop, let's say it is using the node number 2 and 3, and another loop is using the node number 4 and 5, means these two loops are not touching each other. So that can be taken as a one pair of two non-touching loop in that, right? So if I say this one, this individual loop is using the node number 2 and 3, and this loop is using the node number 4, right? So now these two loops are not touching each other. So I can take this as a one pair of two non-touching loop in the given signal flow graph. So I'm writing the node number 2, 3, then 3 back to 2, the gain value is minus H2, and this gain value is G2, and another loop with the node number 4, the gain value in that is G5. So here what we have done is that we will have to identify a two individual loop which is not touching each other. So we have identified one set or one pair of loop which is not touching each other. How can we identify whether it is touching or not? These are all based on the node number. We have identified an individual loop. Now we will have to see this is a loop which is using a node numbers 2 and 3, and this loop is using a node number 4. This is one loop and this is another loop. What we will have to find out the loop which is not touching each other. So I can say this is a one pair or one set of loop which is not touching each other. So I can write down the gain values of the same. I'll have to write down all these given one pair of the loop which you have identified. You will have to write the gain values of that. So that is G2, G5 into H2. Okay. Second thing, we will also have to find out any other loop which is not touching each other, right? So if I say 2 and 3, in this loop is having the node number 2 and 3. So we cannot take it as a non-touching pair, as well as this loop is using 2 and 3. This is also having the same node, and this is also having the same thing. Now if I try to map this loop with the other one, 2, 3, 4, all these are all having the same thing, right? So will you be able to find out another set of or another pair of individual loop which are not touching each other? Yes, there is another loop. Here we have got a loop which is using the node number 2, 3 and 5, but there is another loop which is the node number 4, right? So now these two loops are not touching each other. So we can write it as a one set or another pair of the loop which is not touching each other. So we can write it out, 2 to 3, then 3 to 5, then 5 back to 2. So the gain values are minus H3 and G2 into G6, and the another loop gain value is 4. There it is given as G5. Got it? Now what is the next step? Write down these gain value as P22 is equal to minus of G2, G5, G6 into H3, right? So whenever you write the gain value, you write it in the order, right? G2, G5, G6. Don't write it like G6, G5 into H3. Whenever you start with it, let the G be in the beginning, right? Because you have a H also, right? Let the G be in the beginning and H at the last. As well as these values also have to be written in the order, G2, G5 and G6. Okay, now can we find out any other loop which is not touching each other? No, now all these loops are all, we have found two pairs, that these two pairs only is not touching each other, but all these individual loops will touch each other. So what is the next step? We will go on finding it for three non-touching loop, right? Because we will have to find out individual loop, then two non-touching loop, then three non-touching loop, right? So here we will have to see, is there any loop, right? Any three loop which is not touching each other, right? So if we are trying to find out, this is not given under. Okay, so write a heading as three non-touching loop, and there is no three non-touching loop available in the given signal flow graph. Heading as three non-touching loop. Okay, there is no 3 non-touching loop available in the given signal flow graph. Okay. So what is the next thing? We will have to write down the formula for the same. Now how many forward paths we have found? We have found 2 forward paths. So my Mason's gain formula equation will be like this: P1 del 1 plus P2 del 2 divided by del, right? As we had 2 forward paths, now my K value will be 2, right? So since my K value is equal to 2, my equation P1 and del 1 will be there, right? So this summation is there, so it will be P2 del 2 also. So the Mason's gain formula is written over here. Okay. So now we have also found out what is the P1 as well as P2. What is left is free here is that we have not written the del 1 and del 2 value. We will have to write down the del 1 and del 2 value at the end, right? So we will not be able to find out what is the gain values of del 1 and del 2. Why? Because only after writing down these individual loop, we will be able to know what is the del 1 and del 2 value. Because as per the equation that is given, 1 minus, right? So we will have to write the individual loop which is not touching with the first forward path. For del 2, we will have to find out the individual loop which is not touching with the second forward path. Now, this is my first forward path, right? So 1 to 2, 2 to 3, 3 to 4, 4 to 5. Now, if I try to map all these individual loops on this first forward path, means all these loops will be touching with the first forward path. So my del 1 value will be 1 over here, right? So now coming to the second forward path, now if I am trying to map all these 4, 1, 2, 3, 4, these are all will be touching because the node numbers in the second forward path are 1, 2, 3 and 5. Look at this individual loop, it has 2 and 3, yes, it will be touching. This is using 2, 3, 4, it will be touching in the second forward path. These are the nodes 2, 3, 4, these are also will be touching in this. Look at this individual loop 2, 3, 5, that also will be touching in the given signal flow graph. But there is a loop which is not touching here. What is that? Node number 4 and the gain value is G5. So here what happens is that here what you need to write 1 minus what is the gain value of this loop, that is G5. Okay. So how to write the del 1 and del 2 value? Del 1 you will have to find out in the first forward path. In the first forward path, you will have to see whether all these nodes are all touching with this one, right? So if it is touching, the del value will be 1. Now in the second forward path, there is one loop which we have identified, individual loop, which is not touching with the second forward path. So my equation is del 2 is equal to 1 minus G5. Fine. So the next step is that we will have to substitute in the below equation. Before that, you will have to write down what is del means. Del is nothing but 1 minus sum of individual loop, then plus non-touching loop of 2. We have found out 2 pairs of non-touching loop that has to be written over here. Now del I can write it like, so 1 minus, what are these individual values? G2 H2, then plus G5, then minus G2 G3 H1, then minus G2 G3 G4 H3, then P15 is minus G2 G6 H3. So if I write here, this will be minus G2 H2, then second individual loop gain value is G5, then my third individual loop gain value is minus G2 G3 into H1 minus G2 G3 into H1, then the fourth individual loop gain value is minus G2 G3 G4 into H3, then my fifth individual loop gain value is minus of G2 G6 and then H3. After that, we will have to write down the two non-touching loop gain values also. That is plus, we have found two pairs. One is minus G2, G5, H2, then minus G2, G5, G6 into H3. Right? So we have wrote everything individually. What is P1, P2, del 1, del 2, as well as we have wrote what is del also. Now just substitute in this formula, Mason's gain formula. Then we will have the overall transfer function of the given signal flow graph. Right? So now T is equal to P1 is G1, G2, G3, G4. Then P2 is G1, G2, G6, right? So which has to be multiplied with 1 minus G5, G1, G2, G6 has to be multiplied with 1 minus G5. Okay. So the next is the whole divided by this del value. Del is equal to 1 minus these gain values has to be written over here. This is my overall transfer function of the given signal flow graph. I'll give you time to write the final overall transfer function of the given signal flow graph, right? So I have written T is equal to what is in the numerator is P1 into del 1 plus P2 into del 2 that I have written. Then the denominator we will have the delta gain values. That has to be whatever that you have written is write it in the denominator of the overall transfer function equation. Okay. Take down the next problem. Convert the block diagram into a signal flow graph. Convert the block diagram into an signal flow graph and use Mason's gain formula to find the overall transfer function of the system. The question is convert the block diagram into an signal flow graph, use the Mason's gain formula to find the overall transfer function of the system. Right. Now, so far the problem was given in a signal flow graph itself, but here the problem is given in block diagram. So what we need to do is that this block diagram has to be converted like signal flow graph. Then we will have to use the Mason's gain formula to find out the overall transfer function of the system. Right. There is a method to reduce or to find out the overall transfer function of the system in block diagram reduction itself. Right. So we will also be seeing it in the coming lectures. There is a method which will take or reduce these blocks and we will be able to get the overall transfer function. But here the problem is asked convert the block diagram into a signal flow graph. Then you have been asked to use the Mason's gain formula like this, right? So now the first step is that we will have to note it down the nodes in the block diagram, right? So nodes means we have 1, 2, 3, 4, 5, right? So likewise here we will have to identify which are the things can act as a node, right? So node means where the branching point also may leave or the branching point also will come and join in that particular node. So first is that the input this as well as the output has to be taken as a node numbers, right? So one and the other one has to be taken as a node number. That is the first step. The second step is that wherever you have a branch point, that means this is a line that is going from summing point to the G1, but there is a line is also moving, right? So this is called as a branch point. This branch point also has to be taken as a node, right? So I have a branch point here and I have another branch point here also. So now these two has to be taken as a node value. Then the third one is that you have a summing point here. So the summing point also has to be taken as a node number, right? So what is the first step? Input and output has to be taken as a node. The second one is wherever the branch point is there, that has to be given as a node number. Then where you have a summing point also has to be taken as a node number. Now you can give the numbering 1, then this can be taken as a 2, then this is 3, then this will be 4, then 5 and 6, right? So we have identified 6 nodes. If you have identified the 6 node, then we will be able to draw the signal flow graph. So first you draw line there where you just do mark your all 6 node, 5 and 6 over here. Thing is that converting a block diagram into a signal flow graph, first step is that we will have to identify the node. So to identify the node, 3 logic. One is input and output should be taken as a node. Second is branch point should be taken as a node. The third one is the summing point. After that, you will have to give the numbering 1, 2, 3, 4, 6. So since we have given that numbering like that, after that we can draw it. Now, in between 1 to 2, right? So what is the gain value, right? So if anything is not given, you just take that gain value as a 1. Right, so this is R of S, then this is C of S. Okay, so between 1 to 2, you don't have any gain value that is given, so you can take it as a node number 1, and the direction is like this, right? Because from our input, it is given to a summing point, which is a set point. So it is the direction is like this. So you will have to mark the direction 1 to 2 like this. Now, from 2 to 3, what is the gain value? The direction also goes to the G1, then from G1 to G2. So from 2 to 3 also, you don't have any gain value that is given. So you can take it that as a 1, right? So as well as from node number 2, it is also moving to the node number 3. But to the node number also, it is coming from 4 to 2, right? So I'll have to draw it from 4 to 2 because this is the point from where it is leads to this value, right? So I have taken it as a 2 to 3, the gain value is 1 I have taken, but there is a summing point which is coming from the node number 4 to 2 also. So I am taking 4 to 2 and the gain value has to be written as H over here, right? So now the H should be positive or negative, right? So that also has to be determined. Now, from 4 to 2, when it is joining at the summing point, what is the sign that is given? It is minus. So if minus is given, this H value has to be taken as a minus. Got it? So if it is plus and plus, then this H value will be plus H, right? So now we have found, stopped with 2 also. Now go for the third one. Now we have from the third to 4, there is a direction like that. What is the gain value? G1, as well as from 3 to, it is also moving to the node number 5. So from 3 to 5 also it is moving. The direction is in the forward direction. What is the gain value? G3. Okay. So now from node number we have also moved to the node number 5. The gain value is G2. 4 to 5, the gain value is G2. Next, 4 to 2 also is already moving. We have drawn while we are looking at the node number 2. Then 5 to 6, there is no gain value is given, so we can take it as a 1. Understood? Is there any doubts in that? You will have to just follow it up. What is the node number? How do we mark the node number? I've give you three formulas to find it out, right? So input and output, then all the branch point, then all the summing point, then give the numbering. After giving the numbering, just you will have to draw the signal flow graph and just mark the direction, right? So now, after plotting this thing, now our regular procedure to use the Mason's gain formula for finding out the overall transfer function of the system, right? So what is the first step? We will have to write down the forward path, right? So what is the first forward path? From 1 to 6 we can take it. So node number 1 to 6, right? So what are the gain values are there? 1, 1, G1, G2. So my gain values are G1, then G2. So P1 can be written as G1, G2. Right? So is there any other forward path in the given flow signal flow graph? Yes, that is 1 to 2, then 2 to 3, then 3 to 5, then 5 to 6, right? So I can written as 1 to 3, then 3 to 5, then 5 to 6. The gain value is G3, and here it is 1. This one also is 1. So my P2 value is equal to G3. Second forward path gain value is G3. What is the next step? Finding out the individual loop. Right? So how many individual loop present in the signal given signal flow graph? How many individual loop? Okay, we'll find out. 2 to 3 forward direction, 3 to 4 forward direction, then 4 to 2, right? So can we take this as a one individual loop? Yes, we can take that as a one individual loop. The node numbers are 2 to 4, then 4 back to 2. The gain value is minus h and 1 into G1. So P11 can be written as minus of G1 into h. Right. So is there any other individual loop present in it? Any other individual loop? No. There is only one individual loop. So if there is only one individual loop, then we will not be able to go for two non-touching loop also, right? So that we will have to just stop with it. Then you can go to the formula, that is Mason's gain formula. T is equal to 1 by del summation k pk into del k. So what is my k value? There are two number of forward path. So it will become P1 del 1 plus P2 del 2 divided by delta. Okay. So now, what is the value of del 1? Del 1 is 1. Del 2 is? Del 2 is also 1. Why? Because in the first forward path, this individual loop is touching. In the second forward path also, this individual loop is touching. So my del 1 and del 2 value is 1 and 1. Write down the answer. The overall transfer function of the system T is equal to, my P1 is G1, G2 into del 1 is 1. Then P2 is G3. My del 2 values, that is also is 1. Then what is my delta? 1 minus sum of all individual loop. We have identified one individual loop, that is G1 into H, right? So already there is P11 is minus G1 into H. So 1 minus, it will become plus over here, right? So this is our overall transfer function of the system, right? So why this is 1 plus 1 G1 H? We know the formula 1 minus sum of all individual loop, right? So what is the value that is present over there? Minus G1 H, right? So this minus and this minus will become plus. So it is 1 plus G1 into H, right? So in today's lecture, we have solved one problem with 5 individual loop and 2 non-touching loop, and we have derived the overall transfer function of the system. And in the other problem, I have taught you to convert the block diagram into one signal flow graph. Then we have found the overall transfer function of the system also, right? So we will see the more problems in the next classes. Thank you.